Welcome back. So we're gonna jump into example number 2. We're gonna find the derivative of this function that has logarithmic expressions. So in this case, we have a function f of x that is equal to 4x to the 7 times the natural log of x. So of course, this is a type of logarithmic function, right? Or a combination of, and we're asked to find the derivative. Now, of course, you already know that there is a hint here that we're gonna be using the product rule, but I want to argue why we need to use the product rule, and the reason is because we have a product, right? We have a product of this function times this function, right? They're both functions because they both involve in terms a function of x, right? So if we're gonna use the product rule, why don't we just go ahead and rewrite here one of the write down the format of this. U prime times V plus U times V prime, right? All right, so we're gonna use that to find the derivative of f. So we'll take the first, the derivative of that, and then multiply by the second one, plus now the first one by itself, times the derivative of the second one, right? By doing this, we already applied the product rule, and we don't have to worry about the product rule anymore. All we gotta do is just focus on the little pieces, right? All we gotta do is just take the derivative of those two. For the first one, we're gonna use the product rule. So the derivative of this is bring down the 7, multiply by 4. That's 4 times 7 is 28. Leave the x as it is, and then subtract 1 from the 7. So that's gonna be 6. And then multiply by the natural log of x, right? That one's just carried over. Carry over for x to the 7, and then multiply by the derivative of the natural log of x. And as we mentioned before, the derivative of natural log of x is just 1 over x. All right, and that's it, right? We found the derivative. Now, what we're going to ask here is for us to go a little bit further and simplify as much as we can. So we can see here that we could simplify these two together because we can say that this is a numerator of x to the 7. This is a denominator of x to the 7. So I can do another line, right? So to make it a little more obvious. So imagine that this is over 1. So 1 times x is x. And then 4x to the 7 times 1 is 4x. 4x to the 7. And you can see here that we can simplify these two, right? Because there's technically power 1. So what do? We cancel one of them, so that becomes a 6. All right, so here we can go a little bit further, and we can, technically this is an answer, is we would ask here to practice factoring. So let's factor as much as we can. So in this case, 4 can be factored, and from those two terms, right? This is one term, this is the other term, right? One term, second term, right? That's, we know because that's a plus right there. So we're gonna factor whatever we can. So we notice that there's a common factor of 4 in those two, and there's a common factor of x to the 6 right there. So we can factor a 4 and x to the 6, and we're left with 7 that came from the 28, right? And then the x to the 6 is gone, and so we just carry the natural log of x, and in this case everything is factored out, so you're left with 1. Right, so the derivative of this, the derivative of f is this. All right, so we found the derivative. The next part is to find f prime at e to the 4th. So what we're going to do is evaluate the function and replace every place we see an x, we're going to replace it with e to the 4. Right? So and then so that follows that we're gonna have 4 And then e to the 4 to the 6 power, right? What happens here is when you have a power raised to a power, you multiply the two powers. So 4 times 6, that's 24. 7, and then here it's interesting because if you remember, the natural log and e are inverse of each other. They undo each other, leaving you with a 4 behind, right? So that's going to be a 4. So product of 4. And plus your 1. So we simplify this right here because we can. That's going to be 28 from here plus 1, that's 29. 29 we can just multiply that with the 4. So that's going to be 116 e to the 24. Now in the problem is asked in the homework, I believe it's asking you to write this in the decimal form. So the decimal form for this is going to be 30. By putting this in the calculator, it should give us something of this form.